So let's work on these next two problems wherein we'll have to use Q is equal to ms delta T to figure out one of these four, whatever we're asked for. And for the first problem, we have this in which we're asked how much heat is needed to warm water. Okay, so again, we're going to use that equation. Here, it looks like the one that is unknown is Q. Okay, so we'll write Q is equal to the mass of water, which is 466 grams. Okay, and then times 4.184, that's the S of water, joules per gram degree Celsius. Okay, and the delta T should be the one that you should look out for first. Make sure that you know what's the final and what's the initial temperature. Okay, so it says here from 25, so that should be the initial. Okay, and 98 degrees, so to 98 degrees, so meaning it's the final temp. So therefore, this should be 98 degrees Celsius minus 25 degrees Celsius. Okay, and then if you do the math, you will just get 1,000 or 142,000 rather, 331, which is equal to 142 kilojoules. Alright, it's basically the answer for that one. Okay, and then for the next one, we're asked here actually now for the initial temperature, and we're given the following information. Okay, so we can do that as well. So Q is equal to ms delta T. Okay, remember that delta T can also be expressed as final temperature minus initial temperature. So this one's also ms temperature final minus temperature initial. Okay, everything else is given except for the initial temperature. So we can just plug in the values. Okay, when using Q is equal to ms delta T, make sure that the units will cancel out to arrive at the unit that you desire. So for example here, knowing that the S for aluminum is in terms of joules per gram degree Celsius, I'm going to re-express here Q as 135,000 joules. Okay, so to plug in the values that's available, so that's going to be 135,000. And we're going to affix, don't forget, a negative sign because it says it was released, the heat was released. So this one should be negative 135,000 joules is equal to, you have a kilogram of the sample, let's just convert that to grams, so that's 1,000 grams. Okay, and the S of aluminum is 0.902 joules per gram degree Celsius, and then that will be times 20 degrees minus initial temperature. Okay, don't forget this sign, by the way. Again, the problem tells you that energy was released, so Q therefore should be negative. Okay, it will end up to be negative 135,000 joules is equal to 902. Units that will cancel out are grams. Okay, so this will just be joules per degree Celsius times 20 degrees minus Ti, which is unknown. Okay, if we divide both sides of the equation by 902 joules per degree Celsius, or if we divide both sides of the equation by 902 joules per degree Celsius, we're going to cancel out the units joules, and we're going to end up with negative 150 degrees Celsius on the left side of the equation, and that will be equal to 20 degrees Celsius minus Ti. And if you solve for Ti, that will just be 170 degrees Celsius. Okay.